Hello, this video is for Algebra 1, Chapter 2, Lesson 11. The title of the lesson is Percent Increase and Decrease, where our objective is to find percent increase and decrease. The vocabulary for this lesson is percent change, percent increase, percent decrease, discount, and markup. Got a little cartoon here, suits 50% off, and the salesman's telling this man who's standing here with one half of a suit, missing half the suit, it says, "May I suggest you read the sign again, sir?" He thought he was going to get 50% off the value of the suit. He didn't know he was going to get half of a suit. So who uses this? Well, customers can use percent change to determine how much money they can save, and we'll see that in example 3. So a percent change is an increase or decrease given as a percent of the original amount. A percent increase describes an amount that has grown, and a percent decrease describes an amount that has been reduced. So here we have the formula for percent change. Percent change is equal to the amount of increase or decrease divided by the original amount and expressed as a percent. That doesn't make sense. It will whenever we get, by the time we finish this lesson, we will apply this formula to some of our examples in this lesson. So let's look at example 1. Find percent increase or decrease. Find each percent change and tell whether it's a percent increase or decrease. So in example A, we go from 25 to 49. Well, that's an increase, right? 49 is greater than 25, so 25 is our original amount. 49 is the new amount, so we've had an increase. So the percent change is going to be equal to the amount of increase divided by the original amount. So our numerator is always going to be a positive number in this case. So to find the amount of increase, we would have to know the difference of the new price, 49, and the original amount, 25. So we're going to have 49 minus 25. And then 25 is the original amount, represented in blue. 49 minus 25 is 24. 24 divided by 25 is 0.96. And then 0.96 as a percentage. Move that decimal over 2 places to the right. You get 96 and throw the percent sign on the end. So 25 to 49 is an increase. So a change from 25 to 49 is a 96% increase. And this does make sense. And our helpful hint here before solving, describe what is a reasonable answer. For example 1A, 25 to 50 would be a 100% increase. If you were to double it, it's a 100% increase. So 25 to 49 should be slightly less than 100%. And indeed, we see that 96 is slightly less than 100%. So 96% definitely makes sense. Now we're going to go from 50 to 45. So our original amount is 50. Our new amount is 45. So this is a decrease. So we need to know the difference between the original amount and the new amount. So the amount of decrease is going to be represented by 50 minus 45. The difference of 50 and 45 is 5. Remember, the denominator is always, whether it's increase or decrease, the denominator is always the original amount. So we have 50 here. So 5 over 50. 5 divided by 50 is equal to 1 over 10. 5 divided by 5 is 1. 50 divided by 5 is 10. 1 over 10 is 10%. If you were to put that into a calculator, 1 divided by 10, you would get 0.1. Move the decimal over 2 places, get a 10, and put the percent on the end. So if you like turning your fractions to a decimal and your decimals to a percent, you could always use a calculator or that for that, because remember, every fraction is a division problem. Numerator divided by the denominator. So 50 to 45 is a decrease. So a change from 50 to 45 is a 10% decrease. So let's do a couple of them here. In the first one, 1A, if we go from 200 to 110, this is a decrease, right? To know the difference, we're going to have to know 200 minus 110. That's going to give us a positive number. Our original amount is indeed 200. So 200 minus 110. Well, 200 minus 100 is 100. Minus 10 more is 90. So we'd have 90 over 200. And then if I go ahead, I could simplify that if I wanted to. Oh, here we go. Let's divide them both by 2 to get to 100. 45. Now 45 over 100 is 45%. So it's a 45% decrease for that one. So 45%, and it is, and we'll put D for decrease. On another one, let's do an increase, 80 to 115. So we're going to have to go, I'll put it over here. We're going to have to do the difference of 115 minus 80, correct? We want a positive number. Our original amount is 80, so we'll put 80 here for the denominator. Now, 115 minus 80, and that should be, what, 2035, right? There we go. I mental math that one. 35 over 80. Now, 80 to 100 is not that simple, so let's go ahead and do 35 divided by 80. So 35 divided by 80 is going to give me a decimal of, I get a good one here, 0.4375. I was just expecting 2 numbers, but now to change this decimal to a percentage, we want to move the decimal over 2 places and get 43.75 and throw the percent sign on the end. So I end up with a 43.75%, and this is an increase. So we'll use I for increase, and we'll just grab all this, group it, and move that right over here for that. There we go. 80 to 115% is a 43.75% increase. Does that answer make sense? Well, a 50% of 80 would be 40, and 80 plus 40 would be 120, which is just a little bit more than 115, and 50% was a little bit more than 43.75%. So indeed, this 43.75% does make sense. Looking at our next slide here, we have example number 2, finding the result of a percent increase or decrease. So it says find the result when 30 is increased by 20%. So we want 20% of 30, right? So 20% as a decimal is 0.20 times 30. Remember, of means to multiply. So 20% as a decimal, 20% here. 20% of means to multiply 30, and we would get 6. So now we need to add 6 back to the original amount of 30. 30 plus 6 is 36. So therefore, 30 increased by 20% is 36. There's an easier way to do this, and we'll look at that later on in another example. Next, we have find the result when 65 is decreased by 80%. So we want 80% of 65 and then subtract it from 65, right? So 80% as a decimal is 0.80. 80% of means to multiply. We're going to multiply times 65. So this is 80% of 65. We calculate that out, we would get 52. So now let's go ahead and subtract 52 from the original amount of 65, and we would get 13. So we see that 65 decreased by 80% is 13. And again, there is an easier way to do this, and we'll look at that in a future example. Common applications of percent change are discounts and markups. A discount is an original amount by which the original price is reduced. So discount is equal to a percent of the original price. The final price is going to be the original price minus that discount. Whereas a markup is an amount by which a wholesale cost is increased. Whenever a company buys a product, they have to raise the price on it to make a profit. Whenever they raise that price, that's known as a markup, and it's usually calculated as a percentage of whatever their original cost is. So the markup is a percent of the wholesale cost, the amount that the retailer, the people selling it, purchased it for. And the final price is going to be that wholesale cost, what they paid for it, plus the markup on it, what they're going to make off of it. That would equal the final price. So here in example 3, discounts. Admission to the museum is $8. Students receive a 15% discount. How much is the discount, and how much do the students pay? So we're going to see that other way of doing it here in method 2. So let's go ahead and look at the way that we've been doing it in method 1, and then we'll look at what I feel is a much easier method in method 2. So here we have method 1. A discount is a percent decrease. Whenever you get a discount on something, the price goes down. So find 8% decreased by 15%. So 15% as a decimal is 0.15. 15% of 8 equals $1.20. So now we're going to subtract the discounted, the amount of the discount. It says how much is the discount? The discount is $1.20. Subtract that from the original price, $8. 8 minus $1.20 is $6.80. So the cost would be $6.80. Now, there's another way to do it. If you're getting 15% off, the original cost is 100% of the price. You're getting 15% off. So technically, you're paying the difference of the discount subtracted from 100. So if the discount's 15%, subtract that from 100, you're actually paying 85% of the original cost. So you could just do this as calculating, instead of doing 15% off, find out what 15% of the original cost is, like we did in method 1, and then subtracting it from the original cost. You could just go ahead and realize that, hey, if I'm getting 15% off, that means I'm actually paying 85% of the original cost. So 85% is a decimal, 0.85. The original amount, $8. 0.85 times 8 is $6.80. So, this is to find the discount. So 8 minus 680, it's $1.20. Well, we found that out up here. If we just need to know the discount, we could have done it up here and known that. But notice that if we use the concept of that we're paying the difference of the original 100% minus whatever the percentage of the discount is, that's going to show us what we're actually paying. Then we could just do like we did in this line here. In both times, we get to a $6.80. I personally think that's a little bit easier way to do that. Helpful hint before solving, decide what is a reasonable answer for example 3A here. A 25% discount is $2 off, so a 15% discount will be less than $2. And indeed, $1.20 is less than $2. Now, here we have in this one, I think they're going to show us the way that is actually easier. Remember I said there's a couple ways that were easier. This one here we had about discounts, and there's an easier way to do markups. If we look back here, markups where something was increased, we found out what it was, we found out what the percent was, and then we added it to the original amount to get that. Well, check this out. If you're paying an increase, 30 increased by 20%, right? So technically, you are paying 100% of the original cost, plus you're paying another 20% for the markup. So if you add these together, 100 plus 20 is 120%. So you're actually going to do 120% of the original cost. Remember, of means to multiply. So let's change 120 to a percent to a decimal. Move the decimal over 2 places. We would end up with 1.2. So 1.2 is 120% of the original cost, which is 30. And just to be certain that I get the same value, let's do 1.2, multiply that times 30, and we get the same exact value of 36. I personally think that this is an easier way of calculating an increase than it is to find out how much is the increase and then add it to the original cost. So that is the easy way for an increase. And then for a decrease, like I had said here, if you're getting 15% off, you're actually paying 85%. So you calculate that as 85% times the original cost to find out what the new cost is. Here we have Christo used a coupon and paid $7.35 for a pizza that normally cost $10.50. Find the percent of discount. So we're going to take the $10.50, the original cost of the pizza, minus what he actually paid, and he got $3.15 off of it. So we know that $3.50 is some percent of $10.50, and that's what we're wanting to know. So $3.15 is some percent, X is the unknown percentage, of multiplying $10.50. Let's divide both sides by 10.50. We get just the X on the right. 3.15 divided by 10.5 is 0.3. Move that decimal over 2 places to the right and throw a percent sign on the end. So the 3 becomes a 30. I'm going to put the percent sign on there. So the discount is 30%. Let's go ahead and do a couple examples here on 3A. A $220 bicycle was on sale for 60% off. Find the sale price. Well, let's do this. Instead of finding 60% of 220 and subtracting it from 220, let's realize that 100% minus 60% equals 40%. So on the bicycle, you're actually paying 40% of the original cost. So we want to know 40% of 220. 40% is a decimal, 0.4. Multiply that times the original price, 220, and this is going to give us an answer of 0.4 times 220 is going to give us 88. So you can buy the bike for $88. Number 3, Ray paid $12 for a $15 t-shirt. What was the percent discount? So in this case, 12 is some percentage of 15, right? So in this case, right, you paid $12 for a $15 t-shirt. So $12, 12, the equal sign is the word is. Remember, your X represents your percentage, and then the 15 is the original OC for original cost. So if I do 12 equals 15, I guess I'll put the 5 first, X, divide both sides by 15. What I do to one side, I do to the other. 15s cancel each other, leaving me with X, and 12 divided by 15 is going to give me 0.8, 0.8. Now this is going to be, move the decimal over 2 places, get 80, throw a percent sign on the end. So in this case, what was the percent discount? You might be thinking 80, but actually that answer doesn't make sense. 80% of 15? Well, 50% of 15 is $7.50, right? So you're only getting $3 off. So actually 80% is what you're paying. You're paying 80%. So what was your discount? Well, the difference between 80 and 100 is 20%. So you actually got a 20% discount. 80% is the percentage that you paid of the original cost, right? The percent of 15 is 12. So you paid 80%, so your discount was 20%. Let's look at markups. Caleb buys necklaces at a wholesale cost of $48 each. He then marks up the price by 75% and sells the necklaces. What is the amount of the markup and what is the selling price? Well, the markup is going to be 75% of 48. So here we have 75% is a decimal, 0.75 of the original cost, 48. Multiply it out, it's 36. So the markup is $36, which they keep doing down here. It says, what is the amount of the markup? And then they calculate the markup down here in method 2 whenever they ask for the markup first. And so the markup shows up here whenever you do that. Now, the final cost is going to be the original cost of 48 plus the markup, and that's going to be 84. So another way you could have done this is, think of it this way. You're going to pay 100% of the 48, what he paid for it. Then you're going to pay 75% right here of the markup. So 100 plus 75 is 175%. As a decimal is 1.75. So you need to multiply the 175% times the original cost. So we're going to write this as 1.75. We're going to multiply that times the original cost of 48. And whenever we do that, I guess I'll write the answer. Oh, here, we can move that over. Let's just, not that. We don't want to move that over. Put that there. I'll leave it where it's at. So let's go ahead and do 1.75, and we'll multiply that times 48. See if we agree with the book. And this comes to 84. So we'll squeeze this in right here. 84, and sure enough, that's what they got there, was $84. Now, by either method, the amount of the markup is $36, and the selling price is $84. Let's look at what they do with method 2, just to kind of cover it. Add percent markup to 100. Oh, they're doing exactly what I just did, right? 100 plus 75%, 175. If you were watching this saying, hey, that's what they doing on method 2. So indeed, 175 is the decimals, 1.75 times 48 is 84. Now what they did here is they figured out the markup. Again, I don't understand why they're solving for the original price in method 1 whenever the first question they asked was, what is the markup? So either way. Lars purchased a daily planner for $32. The wholesale cost was $25. What was the percent of markup? So at this rate, boy, this sure seems like they're doing this the difficult way, right? I kind of like the method. Remember that equation that we had at the beginning? I'm going to disregard this for a moment, see if we come up with the same thing. So he buys a daily planner for $32 and the original cost was $25. So this is an increase from $25 to $32, correct? So let's do and I'm going to use some abbreviations here. In order to get a positive number, we're going to have to do the new amount and subtract from that the original amount. NA for new amount, OA for original amount. We're going to divide that by the original amount. That's what that formula was. If we go back and look at the first page here, right here, percent of change is equal to the original amount of increase or decrease. So we're going to subtract the two numbers so that we get a positive number. Then we're going to divide by the original amount, and then we're going to express it as a percent. So let's go ahead and jump back to that page there that we're looking for. Here it is here. So I've used these abbreviations. NA for new amount, OA for original amount. In order to get a positive number, we're going to subtract the original amount from the new amount, and then we always make the denominator the original amount. So let's plug in values there. The new amount is 32. We're subtracting from it the value of 25, the original amount. We're going to divide by 25. Now 32 minus 25 is going to be, what is that, 7? Bring down our 25. Now let's do 7 divided by 25, and we'll get 0.28. Now express this as a percent. Move the decimal over 2 places. Get 28. Throw the percent sign on the end. I say 28%. They say 28%. So it's interesting how they introduce that formula at the beginning, and then they start doing it in other methods here. So let's look at the way that they done it. They take 32 minus 25 and get 7, which is what we did there. 32 minus 25, and we get 7. And then they're thinking, okay, so we know that 7 is some percentage of 25, right? 7 is some percentage of 25. Divide both sides by 25, right? And we just get x. Then we do 7 divided by 25, which is what I did right here, right? 7 divided by 25. And that equals 0.28. Change it to a percentage, and we get the same markup. So basically what they're doing is they take this concept right here. I always like to keep it, I always just work it right in this formula here, but they've basically taken the formula for percent of change and increase, and then they've broken it down in these other steps here where it kind of deviates from what's over here. My personal opinion is on problems like this, I would stick with this. For years, I've been using this new amount minus the original amount divided by the original amount is going to show an increase, and a decrease would be the other way around. Let's look at what a decrease would be. Decrease, we would have to take the original amount and subtract the new amount, and then divide by the original amount. Okay, so increase this way, decrease over here. Mainly, key thing that you need to pay attention to is, first of all, is it an increase or a decrease? So that whenever you get the answer at the end, you realize whether you have a percent of increase or decrease. Then take your two numbers, subtract one from another in such a way that you're going to get a positive number. Then divide it by the original amount, change the decimal over to a percentage, and voila, you're at your answer at that point. So here we are at our guided practice. So we're going to find each percentage, tell whether it's an increase or decrease. So we got a couple examples here. Let's do 6 and we'll do 5. So let's do 5 first. 16 to 18. Both those are increases, aren't they? Let's find a decrease. Let's do 3 instead of 6. Okay. So we'll do 1 increase, 1 decrease. So 10 to 8. So this is a decrease, right? Now, in order to get a positive number, we're going to have to do 10 minus 8. 10 minus 8. We're going to divide that by the original amount. Well, we're starting with 10. So that's our original amount. So 10 minus 8 is 2. 2 over 10. And then if I divided that and turn it into a decimal, that'd be 2/10. So that'd be 0.2. And then move the decimal over 2 places to the right, I get 20. Throw a percent sign on the end. So this would be a decrease of 20%. Now on 16 to 18, right, this is going to be an increase. So we want the new amount of 18, and we want to subtract from that the original amount of 16, and we want to divide by the original amount. The original amount is 16 here. So 18 minus 16 is 2. 2 over 16 is 2 over 16 here. I can simplify that to 1 over 8. And as a decimal, I usually have that memorized, but let's find out. 1 divided by 8, and oh, that's it. Yep, I knew it was a common one. It's just been a little while. And it is 0.125. So that's a decimal. Move that decimal, or that's a decimal number. We want it as a percent. Move the decimal over 2 places to get 12.5. And throw a percent sign on the end. So this is an increase of 12.5%. Okay. Let me go ahead and erase this here, give myself some writing room so we can calculate some more. Find the result when 40 is increased by 85%. So in this case, we could use what was known as a percent equation. So we want to know 40 increased by 85%. So 40, we could do 40 times 0.85 and 40 multiplied by 0.85, and we would get 34. And then we would have to do 40 plus 34, and that would give us, what, 74. So our answer would be 74. But check this out. If we increase 40 by 85%, well, we have 40, right, over here, adding 40 to it. This is 100%, and this is 85%. So why don't we just go ahead and increase it by 185%? Well, this is a decimal, is 1.85. So let's take 1.85, multiply it times that original amount of 40, and then what will we get? 1.85 multiplied times 40, and lo and behold, we get the same value of 74. I think the second method is easier than finding out what is the increase and adding it back to the original amount. I would rather just add 100% plus whatever the increase is. Let's do another one here, only this time let's do a decrease. Let's do number 10. Find the result when 350 is decreased by 10%. Now you could say, oh, I know 10% of 350, that's 35. 350 minus 35 is going to be 350, well, what, 315, right? So I should come up with 315. My mental math tells me 315. But let's go ahead using the formula here. I could do 350 times 10% get 35, which is what I did in my mental math. So 350 times 0.1 gives me 35, and then I did 350, and I subtracted 35, and in my head I thought 350, take off 30, I get the 320, take off 5 more, and I get the 315. That's where I got 315. So I did mental math that way. Now another way we could do it is if you're getting 10% off, then you're actually paying 90%. So because 100 minus 10 is 90. So you're actually paying 90% of the cost. Well, 90% as a fraction is 0.9. So let's take that 0.9, multiply it times the original cost of 350, and we get 0.9 times 350, and sure enough, we still get the same 315. Either way you want to do it, works out well. All right. Do I want to go into the other ones? The other ones are just the same concepts put into word problems. I think it'd be all right. So, and we are at the 30-minute mark for this video, so I'm going to call it quits at this point. And that pretty much concludes my presentation for Algebra 1, Chapter 2, Lesson 11, percent increase and decrease. Thank you.